This last recording for this module, we'll be looking at Chapter 8 and continuing to look at geometry. And we're going to look at the perimeter of polygons and the area of quadrilaterals and continue looking at those. And so it's the same objectives that we had in the last video. This is a continuation of that. So I just wanted to break it up so that it was not going to be so long. So continuing from the last video, let's look at area of perimeter and parallelograms now. And you'll see that the area formula here is very similar to what we had for the area of a rectangle. Its area equals base times height, or area equals length times width. Base and height are going to be interchangeable for that. And in this case, the reason why is because if we have a parallelogram, so two lines that are parallel, or two sets of lines that are parallel, this set of lines and this set of lines are parallel, and this set of lines and this set of lines are parallel. If we take this and look at it, and then if we can imagine that we just kind of push this box up, or this parallelogram up and over here if we could, and adjust it so that we moved that corner to where it would go up and down, and this corner got scrunched over and it got moved like this too, then we would see that what we really have is we have a rectangle. So a parallelogram, the reason why the area equals base times height, and it works for rectangles and parallelograms, is because it's basically the same dimensions. So when we're going to look at perimeter, the same works as also for a rectangle, and we look at it is 2 times one side and plus 2 times the other side, and that is going to give you your overall perimeter. And remember, perimeter is measured in just simple units of centimeters or inches. So looking at the area and perimeter of trapezoids, now this is a different beast, but that still makes sense when you think about it. So we've got this fancy looking formula over here. A equals B sub 1 and plus B sub 2, and that just means B sub 1 here is B sub 2, so the shorter length and the longer length. And it could be vice versa also. And the main thing is, though, is what this is doing is saying, okay, we're going to take the length of B1, and we're going to take the length of B2, and we're going to find the average of those, because we're going to divide it by 2, then we're going to get the average length of the two parallel sides, so that it's basically going to come out to where, okay, they're about, each average is about that much, and then we're going to go with a common height. And then so what we end up with is we end up with a quadrilateral, and we know how to be able to solve the area and perimeter of quadrilaterals, and so that's pretty easy. The perimeter actually is really easy on a trapezoid, because you're just adding up all the sides, just as if you were walking around the perimeter of a fence. The area is pretty easy also, so let's go ahead, and I think we have an opportunity to look and see how that's done. So in this case, they say, okay, if they're going to find the trapezoid shape of a metal plate, we're looking at the sides. We have B1 and B2, and then we also know the height. So notice that one of the things that you don't need is you don't need that and you don't need that to be able to find the area. Now, when we go for the perimeter, you would need that, but for right now, all you need is B1, B2, and the height. And so plugging in and substituting the values, what we're able to do is we're able to say, okay, the B1 is 7 inches, and B2 is 19 inches. We're going to divide those by 2, and so 7 plus 19 is 26, divided by 2 is 13, and all of that times the height, which we see is 6, and 13 times 6 inches. And in this case, we will go ahead and get our calculator out. And 13 times 6 inches is 78, and in this case it's inches, and remember we're doing area, so it is squared. So that's the inside of inside of that metal plate right there, and that answers the question they're looking for. Let's look at another question. So I want you to go ahead and try to see if you can solve this one on your own. Remember, you're going to need to solve it for not only the perimeter, but you're also going to need to solve it for the cost of the fence. So go ahead and pause your video and try this one on your own. Okay, we're back. So let's go ahead then and look at this. I like to be able to draw a picture if I can. So in this case, we're going to go, this is 45 yards by 58 yards. And so I know that if this side is 45 yards, then this side is 45 yards, and then this is 58 yards if the other side is 58 yards. Okay, so let's go ahead then and look at because we are going for perimeter, and in this case we can say P equals 2 times the length plus 2 times the width, and so in this case the length is 58 or 45, either one, doesn't really matter, and 2 times the width, which is 45 in this case. And so we can say 2 times 58 is 116, plus 2 times 45 is 90, and then so we can say that the total perimeter equals 206 yards. And remember though, what it's asking for is it's asking for the total price of the fence at $16 a foot. Okay, well, one of the things that we make sure that we see is we go, okay, well, this is in yards, and we know that we want this in feet, so let's go ahead and get the conversion. There's 3 feet to a yard. And so we're going to go ahead and have to calculate that, and so that's going to be 618 feet, because our yards cancel out here. And at 618 feet times $16 a foot, get the calculator back out again. And that's going to be a rather spendy fence at $9,888 to be able to have a fence go around the playground. Looking at the next one. Go ahead and try to solve this one on your own. So go ahead and read over it, draw a picture, pause the video. Okay, we're back, so let's go ahead and see how we can solve this. It says the cathedral ceiling in a family room has 2 opposite facing walls, each with the shape and dimensions that are shown in the figure, and we'll look at the figure below. That probably would help for you to be able to see that actually in solving this problem. So let me go ahead then, and I'm going to lower this down, and then I'm going to give you a chance to solve this after you get a chance to see the figure. So I apologize about that. I'll go ahead and bring the whole thing down, and then we'll solve it together. But go ahead and pause the video now if you want to be able to try to solve this one on your own. Okay, so looking at this, let's go ahead and see the shape that we are looking at. So we see that we have a trapezoid here because we have 2 parallel lines, and then we have 2 lines that are not parallel. So we know that we're going to have to use this formula that's down here to be able to solve this problem. And We also see that we're going to need to convert these dimensions into something that we can work with a little bit easier than feet and inches. So let's go ahead and convert this to a decimal for each one of these. So 11.9 will be 11.75 because 9/12 of a foot. 10 feet 6 inches will be 10.5 feet, and 8'3" will be 8.25. Okay, so now we have those dimensions. Let's go ahead and substitute into here what we've got for our problem. And I'm going to actually get this down and give myself a little bit more space up here. Okay, and so let's go ahead and calculate this in. So we're going to say A equals, so B1 in this case, we'll call this one B1, doesn't really matter, and then we'll call this one B sub 2. B sub 1 is going to be 11.75 plus B sub 2, which is 8.25, over 2 times the height, which is going to be 10.5. Okay, so now let's go ahead and finish or work on the calculations. 11.75 plus 8.25 is going to be, let's see, that is 8.25 plus 11.75, and that's going to be 20. Okay. Over 2 times 10.5. And so we'll have 10 times 10.5, and that will be 105 feet squared. So there you go. And that is how to solve that problem. Okay. That concludes this chapter.